today we're talking about Mongo backups and more specifically the state of the ecosystem. So what I'm going to talk about is really what type of backups can we take, and then what tooling exists to do these types of backups, what complications come with sharding, and then finally I'm going to talk a little bit about a tool that we have in Mongo Labs that I use for, I'll give you an introduction of who I am, but my team uses for remote DBA in Percona to take backups for those customers. But I wanted to open source that and make sure it was in Percona Lab because there's not a good open source tool to do sharded consistent backups. So I felt the community needed that. All right, so my name is David Murphy. I am the practice manager for MongoDB at Percona, which means I'm over consulting, support, engineering roadmaps, Percona toolkit for Mongo, PMM support for Mongo, evangelism, tracks for this conference. Just, if it touches Mongo, I'm probably in a meeting or running the meeting. And wishing I could do more dev work. But before Percona, I worked at ObjectRocket, which was a high-performance MongoDB database as a service. They're over in the expo hall. It's a great group. It kind of provides hardware plus like Cadillac service level for the people that just want Mongo to work and don't want to think about it and want to shard, and they'll help you pick a shard key kind of stuff, which is nice, but it's a little pricey because it is a very full-fledged Cadillac level service type thing. It's not like RDS from AWS. It's a proper platform as a service DBAS. But before that, so there I was the first DBA there. I was employee 6. I helped build out the team. And I brought somebody over from the previous company who she's now given a lot of talks today, Kim Wilkin. She's the lead DBA there now. But before that, we both worked at Electronic Arts. And I was the global NoSQL, MySQL architect for Electronic Arts. I worked on games like FIFA and pretty much all the sports titles and Dragon Ages and stuff like that. And I helped architect their solutions. And I'll tell you, FIFA was the most complicated one because it's a beast. But I've also used MySQL since 3.22, and I'm a Mongo Master alumni, which if you don't know what that means in the Mongo community, there was a group of us that have been using Mongo for a very long time and we were recognized as experts in the industry, and we would be flown out once a year before Mongo's conference to discuss with them what we felt is needed by the community, and we were those community advocates. As well as we had mailing lists and discussions and all sorts of stuff throughout the year. They've kind of changed that program, and so most of the original ones are now alumni, and they try to refresh the list every year. But I was also a contributor to Mongo, and I've been doing it forever. So today's backup types are really, we start with logical. I think everybody knows what a logical backup is. It's just, it takes the binary data, it turns it into text-based, and then typically you zip it and stuff like that. But to restore it, you have to rehydrate it because your index data turned into a single line that says build this index rather than the actual contents of the index. Some things about MongoDump that you may or may not know. If you pointed it with the host flag to a replica set member, it will connect to that replica set member, realize it's a replica set, and then reconnect to a secondary member to do a dump. If you connect it to a Mongo S, it is going to just go to a primary and do the dump. This is very important because you might think that, oh, I can get a consistent Mongo backup through a Mongo S, and you can't. You can't get operations that occur during the backup may or may not be in the backup because it can't have an op log to track what's happened since the start of it to get to that consistent point through the Mongo S because that's disabled. But then also it hits your primaries, which is generally not something somebody wants to see. It doesn't really protect against lag secondaries either. It picks a secondary that happens to work at the moment. And so it might get a really lagged one, depending on where you're running it from, where the node is, who responds first kind of stuff. And also a single node can't be backed up consistently with MongoDump. This is the same thing as with the Mongo S. There is no ability to use the -- oplog flag. So from the point that I start it and it starts table scanning my collections, if I insert or update a document at a position before or after where that cursor is, I may or may not have that change in the data file. And so it's a very squishy from the beginning to the end of that backup. I may or may not have data, which might be acceptable in some situations, but I generally find that as a DBA from the RDBMS world, terrifying that my backup is squishy to more than like a millisecond or two. And so it's just important to understand that. Generally the restores take a huge amount of time. 3.4 changed some stuff with Mongo Restore, just so you understand, where indexes are built first now and then the data is loaded in. So it's not quite as bad as it used to be, because it used to load all of your data and then build an index and then build the next index and then build the next index. And I regularly would see initial syncs and restores take 3 days to 10 days to happen, depending on the size of the infrastructure. And it was just like, you're sitting there just crying the whole time because you're hoping it doesn't break, because you're going to run out of oplog if you're going to have to restart it. But then we go into the next level, which is LVM snapshots. I'll talk about NFS here in a second. But if you've not ever done an LVM snapshot, basically the way it works is it creates a virtual disk that it starts spooling all the changes to instead of actually applying them to the main disk, so that you can copy your data or send it somewhere else. And while it's doing that, all those writes are spooling on the copy on write table, which is the cow. And if that fills up, the snapshot just suddenly dies and things get merged back in. But it also is more expensive. Your IO will slowly get slower and slower the longer that LVM snapshot is present. So it's not horrible, but it's good to understand that behavior pattern. And then with snapshots, though, it's a binary backup. All you're going to have to do is point a MongoDB to it, and it's going to start up. However, to get a good snapshot, you're going to have to fsync and lock the database to fully freeze it so that it can quiesce and sync that data real quick. And then you can snapshot. Otherwise, you're going to have half-written data. You're going to do a recovery. And you may be consistent, you may not, because the thing to remember in Mongo is checkpointing or syncing is usually every 60 to 120 seconds, depending on the way you've configured it. So it may or may not be exactly what you expected out of it without that fsync and lock. With the fsync and lock, it will be exactly to that point. And so it's really good, it's really fast, but it has performance issues with that cow. Now, when it comes to iSCSI, NFS, EBS, things get a little more interesting. They can have some deduplication stuff to save some space rather than having, 7 copies of 100% of the size of your database. And the copy on write table could be a lot cheaper depending on how they're implemented. However, if you're using Mongo mmap v1, do not use NFS. I suggest you do not use EBS volumes. I suggest you use ephemeral if you're on mmap v1. This has to do with the fact that if your networking slows down a little bit, because there's some shared networking on AWS between your EBS volume and your network traffic, you will suddenly have some really bad performance and really bad locking where you might as well have been using my ISAM the whole time. But a lot of these more advanced SAN type functionalities will have incremental backups just built into them. NetApp, for example, if you're using that, you don't need to fsync and lock. I don't know why. It seems to always work, and I never have bad recovery points. It has something to do with the way when it's saying to write it, it's acknowledging in the NVRAM, so it's doing something different that the normal controllers aren't doing. No, with a NetApp. And it has to do with the way NetApp is using some flash memory, I think, to do some certain acts. Because like in normal NFS, it'll send the write request, and then that returns, and then the client has to then send a commit, and then that returns, and then it's finally done. Whereas with a NetApp, it sends it, and the NetApp responds with a committed right then and there. And so you have a lot less back and forth. SolidFire is a little bit different. I've done some testing on SolidFire. it does a lot of the same behavior, but I've never tested it for if it was going to have corruption on those recoveries. So I would think that it behaves like the NetApp, but I wouldn't want to guarantee that. Other engines are possible to use on NFS storage too, but I don't generally suggest that. I still suggest an iSCSI mount point if you're going to use an NFS type thing. Then we also have hot backup. So hot backup is something we've added to Mongo's ecosystem, where you can just run a command, which is db.admin command create backup backup dir where you want it to be, and it will take and it'll make a binary copy of your data, which is different than a snapshot because I don't have to fsync and lock. I'm actually talking to the database engine to do this, so I know that it's safe to do it. I know that I'm getting that consistent point, because internal to WireTiger and Mongo Rocks, we do actually have transactions inside the engine, even though Mongo doesn't have transactions in user land. And so I can do some really smart stuff with their ACID support. Again, this is just like a snapshot. It's a full duplication of data. So it's expensive from a storage perspective, but your recovery time is almost nil. And so it's probably my preferred method, to be honest, because it takes longer than a snapshot, but I can trust that the database itself was making the decision on what was safe rather than the OS trying to guess at what was safe. So there is a really good tool out there, and I would be lying to you if I didn't say it was the best tool out there for backups, and that is Mongo Ops Manager. It is the best one. It is also the most expensive one. It is not open source. It is closed source. It is $2 a gigabyte per backup. So it goes up in price quite quickly, but it does kind of an initial sync. And then from that point, it does some oplog streaming. And then every once in a while, it does a sync period where it creates a kind of a marker in the metadata to say, all of these deltas up to this point is a backup to this hour, and then this 10 minutes plus the hour, and then this 10 minutes plus the hour. And it's quite useful. If you had a Mongo Enterprise contract, you could do the on-prem version, which is a little cheaper, but you will be having, I think it's like 7 machines that you have to build to support the backup infrastructure. It's quite complicated, but it is very robust and it does a lot of cool stuff. Atlas is backed by the same thing. So if you were doing backups in Atlas, you would be getting that. Very good tool. You don't need any other tools if you're using that, and you have the finances to where you can afford that backup. But there are complications with sharding that you should be aware of. The Mongo Ops Manager and the Percona tool that I'm going to talk about here in a minute both help solve these issues. They approach it in different ways, but they are fairly similar in their behavior. So just at a high level, none of your logical, your binary, or your snapshot backups are sharding safe. They're not sharding safe because they are run on a single MongoD that it does not have a cluster-aware view. So it doesn't know that, hey, I need to spawn 3 copies of this because I have 3 shards and I need to wait for them to all be done before I say that I'm done and I'm snapshotted. Also, like if you're doing snapshots, how do you send at the exact same nanosecond the command to do a snapshot to make sure they all snapshotted at exactly that same point? It's near impossible because you're going to have some amount of jitter on your network just getting to those 3 different nodes. Or you're going to have some amount of jitter on the clock. Even if you're using NTP, there's going to be some skew that still can occur. As a result, Ops Manager, up until this point, is the only mainline tool that does the snapshot supports. It doesn't actually have true point-in-time recovery. What it has is it will recover to those snapshot points of the metadata I was talking about. And then if you had recorded the oplogs, you could then apply some oplogs to get to the very exact position you need. But that's a little more specific and hands-on than it looks like in their manual. Because it is a point, recovering to those micro snapshots that they're doing is technically a point in time recovery. It might not be to the point in time you wanted though. And so with the consistency issues, basically what you would have to do is each shard has a different size backup and will finish at different times. And the way the Mongo dump with the --oplog flag works is the second it starts doing a dump, it starts recording the oplog changes. But because they're not aware that it's waiting on other dumps, that finishes too soon. So if you have 20 gigs in one shard and 200 gigs in another shard, the 20 gig shard is going to have an oplog to time 1, but the other oplog is going to be time 27. And you're going to have this delta between those. And so your cluster is not really coherent at that point. You could have some data loss if you tried to do that recovery. And so as a result, those are the problems. There's other problems with like, is the balancer off? And is it trying to move data between these shards? And then that delta gets even worse. Did I try to create a new collection? Did I try to drop a database, drop a collection, do any other weird things? All of these things would cause problems with a logical backup. It's kind of the same thing with the binary snapshot backups. They're great at the standalone thing, but while the data drift is different, there is still the time drift. There is still the need for the oplog to get everything to a consistent point. And then on top of these things, you also now have to be backing up the config server metadata to a very specific point in time that matches the data nodes to that very specific point in time. So it's complicated and it doesn't really work. So the question is, how do I fix these problems in the end? And so what we've done is we've gone in and we've made a tool called Mongo Consistent Backup. This is in github.com/Percona-lab. Today we actually launched, we promoted a branch that we called MCB 1.0 to production. So we're like kind of resetting it to a 1.0 version. And we're adding a lot of features to it. But that's an old slide. So in 3.2, I'll talk about that slide. In 3.2, they finally made it to where the config servers could be treated like a replica set and they got rid of the two-phase commit thing it was doing. So now with the type of tool that I'm writing, I can treat everything the same and has a very simple and unique path. What is the consistent backup tool? You could download the code. You could execute the Python yourself manually, set up a virtual environment, all that kind of stuff. Or you can use the binaries or the RPMs that we provide or run the make file. And what that would do is it actually packages all of the Python directory and all of the needed dependencies into a single executable file to where all you need is Python 2.7 on your actual machine you want to do a backup from. Then what it will do is it will spider out to a Mongo S or a replica set and connect to the nodes it needs to do the backups to and pull them to where you're doing your backup. As a result, we also have a Docker file to where you could make and we have published Docker to where you could have a Kubernetes job running this tool if you wanted to, like on a daily basis. Now, it's very immature still, so you have to set up like persistence. You have to figure out how you're getting the config file to it, stuff like that. But it is something that can be done.
And that can be triggered from just one path, for example, when the process code running?
Yeah. Yeah, because like what I do on this normally is I just have a CentOS 7 machine, not into Docker, that runs this binary. The backups go into a folder, and then there's options for this tool to upload to S3. And so that once it does the backup, I compress it, I send it up to S3. All of these things are integrated into the tool. But the high level of how this works is a single node won't work. Like I mentioned, there's no oplog, so I can't be consistent. So I'm going to yell at you if you try to point it to a single standalone node. However, if you point it to a replica set, it'll just do a replica set backup. It's pretty much just like dump with --oplog at that point. It's not anything super fancy. But if you point it to a Mongo S, I will spider out. I will get a secondary. I will run a dump against the secondary. I have another thread for each of those shards that's tailing the oplog to the point that the last dump finishes. And then at that point, if you're on 3.2, it will fsync and lock the config database and dump that as well. But if you're on 3.2 or above, it will go in and it will have been tailing your config servers as just another shard. So it'll just stop that. It'll merge all of the oplog entries it recorded into the backup file or into the backup folder So it's just as if you did a Mongo dump. So the restore process is just the same as if you were doing a Mongo restore. So my purpose there was, I don't want to have to make a new tool for it. You do a Mongo restore like you would have if you took a backup from each one of those shards. It just so happens they're all time locked together. And so that's really kind of the nuts and the bolts of it. And this is really this is the problem that I was saying is, if this shard finishes at that early point, it needs something that's going to tail all the way to this point. And so as a result, that's what we do in this, where these oplog tails stay forward until that final snapshot finished. And then at that point, the system can continue. And so kind of the vision for where we're going with this, we want encryption support. We want the ability to create filtered backups. So I don't care about this database or I don't care about that database. Rocks, we want to integrate more tightly with the queryable backups. However, it's complicated. It's going to take a while because I'm recording oplog entries. It's not native to the LSM itself like the Strata backup. So to do a sharded queryable backup, I have to reintegrate those oplog entries into the data files. So obviously that's a long-term stretch goal. That's really complicated. But I want to support uploading to other cloud types and incremental backups and stuff like this. To support this, the release today that I released has modular plugins to it, to where you could take the dump plugin, you could copy it, you could see how, you could look at the interfaces of like do backup and stuff like that, add SSHing to your nodes and triggering a LVM snapshot, and then SCP the files back to this host, and that would be a plugin, and all of a sudden you've added LVM snapshots. We will be adding these if the community doesn't, but it'll take us longer if we're doing it by ourselves. And it will be prioritized based on what our customers need, not necessarily if you needed EBS, but our customers didn't want EBS, they wanted LVM or hot backup, then I'm going to prioritize that one for them. But also I'm going to add an oplog recorder in the future as well. And this is going to be more of a long-term constantly running system. So it's going to be more like Mongo system of just constantly tailing and being able to create snapshots of stuff. And so that's going to be really interesting. We of course are committed to always keeping it open source and maybe even making a restore tool that could partner in with Ansible or something like that to provision additional nodes and then restore to those nodes. Because I don't know about you, but I think I've only ever restored directly back to the nodes I had backed up like once in my life. I always provisioned new nodes, restored there, synced between the two, and then destroyed the old bad version. Because the things that go wrong if you do it the other way, I don't even want to approach. So about this 1.0, we added the compression. We added a YAML config because the options were getting quite long. And actually, as you add a plugin, it automatically gets the new configuration options from the plugin that you created. It's very self-aware in that way. But the YAML was needed because it was getting kind of out of control a little bit. But we also started using ZBackup. If you have not seen ZBackup, you should look at it. I was actually talking to people in our remote DBA services on the MySQL side of the house, how they should look at it, because what it actually does is the first time you take a backup and you pipe something into ZBackup, it will create a repository with deltas and stuff like that, kind of like a github.get folder. But then the second time you do it, it only records the deltas from the first one and then creates this kind of map meta file to where you can say which version of a backup you wanted based on timestamps. And then you can delete old versions and it'll delete those old references and stuff like that. And so it's really quite awesome. It has like AES encryption and all sorts of other stuff to it. So I'm actually liking it an awful lot, but also those are compression values that are actually from the backup tests we were doing. And the blue line was normal. The green line was with using ZBackup. Like, it was super impressive. Other impressive, if we fixed a lot of threading and stuff like that, but the big push to here was the modular nature to make it a lot easier to improve this more rapidly. Some of the other stuff I was talking about is we do RPM builds. Let's see. Oh yeah, we implemented some write concerns and some other stuff. We fixed some of our dependencies, and we have that experimental Docker file that you can start playing with as well. So you can find it at that URL. It's GPL'd. Give us issues, give us pull requests. They'll get through. I get an email on every time anything gets issued or PR'd there to tell me about it, and I will make sure that that tool keeps moving forward. But yeah, that's it. I don't know if y'all had any questions about backups, but that's kind of the ecosystem and where it stands. But the real plan is I want this Mongo consistent backup as it matures more to be a deadline competitor, but simplified for getting those consistent backups that the Mongo tool was giving you, but giving you the choice of where do I store it? How much do I want to spend on the infrastructure to store it, rather than calling out to a service to do it, because it's kind of against the open source Percona way. All right, well then I'm done if there's no questions. Thank y'all.